It might be 82 degrees here in beautiful sunny Southern California, but it's about to be negative 40.
We spent almost $50,000 last summer renting the same climate chamber that Tesla and GM use for sub-zero testing. Why? To find out what's actually required to start a Ram in sub-zero temps. We found that there are 4 temperatures that ultimately determine whether or not your engine fires. Ambient temperature. You have no control over this. It's determined by God. Coolant temperature. Warmer engines start easier. You control this. Heat of compression. The heat generated as the piston rises on the compression stroke. This is determined by battery condition, cranking RPM, and the engine's health. And manifold air temperature. This is where Banks comes in, with scalable wattage heaters that raise manifold air temperature. Since you're not God, let's start with something you can influence: coolant temperature. Your truck was manufactured with a block heater already in it. Sub-zero starts without block heat, as recommended by Ram, will ultimately kill your engine. And a hell of a lot of you are unaware of the damage you're causing on every sub-zero start. I'm Gale Banks. In the fall of 2024, we invented a completely new version of our monster Ram. It improves throttle response, fuel economy, and prevents grid heater bolt failure, which can kill your $30,000 Cummins. And this all-new design improves cold starts in sub-zero temperatures. We called it our Banks Dual Heat Capable Monster Ram. Naturally, we wanted to validate its sub-zero start capabilities. But as you know, Southern California is not known for its cold weather. So we found a climate chamber big enough to drive our 24 Ram into, and then we froze it all the way down to minus 40. Let's start with the basics. Here's Eric to explain why starting a diesel in sub-zero temperatures is so difficult.
A diesel engine doesn't use spark plugs. It relies on compression heat to ignite the fuel. And that works great when everything is warm, but when temperatures drop, especially below 0 Fahrenheit, things that make a diesel efficient start working against it. At sub-zero temps, battery voltage drops, oil thickens, and the cranking power requirement increases. You get slower cranking speed, and that means lower compression temperature. And that's a problem, because without enough heat, diesel fuel doesn't ignite properly. What you get is unstable combustion or no combustion at all. That's why cold start systems exist. Things like grid heaters to heat the manifold air and block heaters to heat the coolant. And their job is pretty simple: raise the manifold air temperature and coolant temperatures so that the engine can actually light off. But there's a problem. Unfortunately, the stock Cummins intake air grid heater assembly, which is used in all 07 to 24 Rams, has a fatal flaw. This bolt, which supplies voltage to the grid heater assembly itself, is notorious for melting off, rolling down your intake, through the intake valves, destroying them along with the piston, cylinder wall, and the head.
Personally, I've seen 5th gen Rams with failed grid heater bolts, some with as few as 34,000 miles on the clock, right here in our shop in sunny Southern California. And that's because the grid heater turns on at any temperature below 66 Fahrenheit or 19 Celsius. And the colder it gets, or the higher the altitude, the longer the heater circuit is active, to a maximum of 75 seconds. And know this, there's not a state in the Union where 66 degrees doesn't happen. This grid heater is from a 21 Ram in the Phoenix area. The bolt was days away from falling into the intake manifold and killing the engine. Now let's talk about what sub-zero starts do to your engine. Because even if it does start when it's freezing, you might be doing damage. My first consideration is oil viscosity.
At room temperature, your oil behaves like oil. At minus 20, minus 30, minus 40, it starts to behave more like molasses in January or worse. Here's Gale and the team at AMSOIL to show you.
This is our cold pour point test that's very visual. We've actually got oils back here in a freezer down to minus 35.
So what have we got here?
Delo diesel oil, 15W40.
All right.
And we've got AMSOIL diesel engine oil, 15W40.
Let's do it.
Whoa.
Oh my.
Holy cats.
Oh, you're kidding
All
me.
right. If you can't get oil to where it needs to go, it can't do its job.
Well, I tell you what, I want a cold start with the one on the right.
Our stuff pours better at cold temperatures. You don't believe me? Well, here you go.
You are kidding me. The thick oil that you've just seen has to be pumped through the engine immediately at startup. If the oil can't flow adequately, you're starving critical components of lubrication right when they need it the most. That's why choosing the correct oil is so important. Here's another challenge you're facing: diesel fuel gelling.
Diesel fuel gelling occurs at sub-zero temperatures when naturally occurring paraffin wax, a component of diesel that provides lubricity and energy density, turns into solid crystals. The crystals grow, clump together, and turn the fuel into a thick, waxy substance that restricts or completely blocks fuel flow. There are two popular types of fuel station diesel. Number 2, or standard diesel, contains higher levels of heavier hydrocarbons, including more paraffin wax. Then you have number 1, or winter diesel, which contains little to no paraffin wax. You give up the higher energy density and higher lubricity of number 2 to avoid gelling in sub-zero temps.
Fuel gelling is so detrimental that Cummins has incorporated a heating element and temperature sensor into the engine-mounted fuel filter housing. The heater isn't computer controlled. It only operates when the key is on and the fuel temperature is below 45F or 7C. Once activated, the heater stays on until the fuel temp reaches 75F or 24C. The third thing you're fighting on a sub-zero start is battery voltage.
Sub-zero temps slow electrochemical reactions inside a battery. For example, with the truck off, the battery's resting 12.6 volts drops all the way to 11.4 volts at -40. Coupled with increased engine cranking demand due to that thickened oil, the voltage can drop so fast when cranking that the entire electrical system struggles to stay online. A common battery rating is cold cranking amps, or CCA, which is tested at 0 degrees. The problem is they don't test cold cranking amps where we're going.
And what happens the moment you start cranking? Accelerated wear.
At sub-zero temps, metal components contract at different rates, altering internal clearances, increasing friction wear. At the same time, poor lubrication during startup puts rotating components like bearings or reciprocating components like pistons at significant risk. Thick, cold oil flows poorly, delaying formation of the hydrodynamic film, leading to metal-to-metal contact. At startup, the oil pump has to draw the oil up through the pickup tube, feeding it to the oil passages in the block and throughout the entire engine. With the oil this cold, it's like trying to suck a Dairy Queen Blizzard through a straw. If the engine starts, combustion introduces rapid heating, creating steep temperature gradients across the cylinder walls.
Picture this. The engine has been sitting all night, and let's say it's cold soaked to -20, and you didn't connect the block heater. You managed to fire it up, but know this. The owner's manual tells you the block heater is mandatory at this temperature. And here's one of the reasons why. During combustion, the temps inside the cylinder are going to be 300F or greater, while the outside of the cylinder facing the water jacket is still -20F. So you have a thermal war going on across a relatively thin cylinder wall. Naturally, it's going to be damaging. In extreme cases, such as no block heat, this can lead to micro-cracking of the inner cylinder wall surface.
Speaking of cylinder damage, cold starting without block heat can also result in incomplete combustion, which can be spotted by black smoke or a mixture of black and white smoke. Pure white smoke occurs when fuel is being injected but not lighting off at all. This unburned fuel can make its way past the rings, strip away the protective oil film, and end up in the oil pan.
And just between us, diesel sucks as a lubricant. So if you see white smoke, I wouldn't continue trying to start without changing something. Bring the camera in. Closer. Starting your engine in sub-zero temps, especially if there's no block heat, is shortening its life. The best way to avoid damage is by keeping the engine warm while it's not running. Now let's talk block heater.
A block heater warms your block by heating the coolant and everything that the coolant touches, thus heating the cylinder head fire deck and the cylinder walls. Now, your oil isn't directly heated like the coolant, but the block heater preheats the oil passages and jump-starts the engine oil warming process.
The Ram Owner's Manual actually gives you guidance on block heater usage. You'll find the Owner's Manual in your glove box. For ambient temperatures below 0 degrees Fahrenheit or minus 18 degrees Celsius, engine block heater usage is recommended. For ambient temperatures below minus 20 degrees Fahrenheit or minus 29 degrees Celsius, engine block heater usage is required. And I want to say something. The guys at Ram know what the hell they're talking about.
Block heat helps, but the final factor concerning Sub-Zero starts is manifold air temperature. The original single heat Banks Monster Ram replaced the failure-prone factory grid heater with a single 750-watt coil heater threaded directly into the casting. And while the vast majority of Rams cold started flawlessly with the single coil heater, we heard from a few customers in places like Canada or Alaska telling us, "Hey, the Monster Ram works great until it gets really, really cold." So, back in November of 24, Gale began designing a dual heat capable Monster Ram which would deliver 1,500 watts of intake air heat. So we started looking for a climate chamber where we could create extreme cold on demand. In April of 25, we were ready for the climate chamber. We decided to work with Thermal Dynamics in Rancho Cucamonga, California, who just so happened to have a multi-million-dollar facility used by OEMs for extreme temperature testing. This is one giant chamber, that's for sure. And here's the key. The Thermal Dynamics climate chamber is very accurately controlled, eliminating guessing. Negative 38 and negative 40. So when we say minus 20, minus 30, or minus 40, that's real calibrated temperature. I don't know how you guys do it. This is cold, measured to within half a degree.
But before we get to the testing, let's talk about the victim.
We used a 2024 Ram 2500 Tradesman 4x4. Stock with the exception of new Interstate AGM batteries, which came highly recommended by our friends up north. For lubrication, we used AMSOIL Signature Series 5W40 100% synthetic max duty diesel oil, which is Ram's recommended viscosity for sub-zero temps. For fuel, we used #1 winter diesel, which is hard to get in Southern California, by the way. We had to sneak in a 50-gallon drum from Arizona. We replaced the fuel water separator, and we ran AMSOIL cold flow fuel additive to further prevent fuel gelling. We wanted to give the truck every realistic advantage without adding external aids that would mask the performance of the Monster Ram's heating system. So no oil pan heaters, no battery blankets, because we were trying to isolate one variable, intake manifold air temperature.
Then we instrumented everything. Temperature sensors, pressure sensors, battery voltage, amperage, cranking RPM, fuel rail pressure. We recorded everything at 25 samples per second with all this real-time data feeding 2 iDash Data Pros mounted in a stealth pod on the A-pillar.
And here's the thing. We didn't even start testing unless the truck had been cold soaked for a minimum of 12 hours. And all temperatures were within half a degree of our target. All right, we'll be back in the morning. This cold soak isn't your iPhone, for example, saying it might have hit minus 30 for a few hours last night. But what you fail to realize is that minus 30 was the low, and then it started to warm up as morning approached. If we set the chamber to minus 30, it's not getting any warmer until we change the target temperature or we generate chamber heat by starting the engine. So the truck is absolutely at minus 30 when we test. And you only get one test per day. Once you add heat to the chamber, you're done. Now you have to wait until everything returns to the target temperature, which takes at least another 12 hours. I'd say that worked pretty well. Let's go have a sweet treat, shall we? So every successful start? Well, that was a $7,000 day. We'd leave the truck in the cell to chill overnight just to do it all over again. Now, let's talk about the actual testing. Despite Ram's recommendations, we tested with and without block heat below minus 20. If you think block heat doesn't matter, it does. Lack of block heat will absolutely damage your engine. So whatever you do, try to never, ever start without block heat at minus 20 and below. However, we did follow Ram's recommended procedure for preheating intake manifold air, including 2 preheat cycles. Diesel preheat starting. This is achieved by leaving your foot off the brake pedal each time you press the engine stop-start button or rotate the key into the ignition position. The second preheat is achieved by going back to the off position waiting 5 seconds, then back to the ignition position with your foot off the brake. Each time you do this, the engine control module energizes the intake air heater circuit for a set amount of time based on manifold air temperature and altitude. As Gale explained earlier,
the colder it gets, or the higher the altitude, the longer the heater circuit is active.
Since the manifold air temperature was warmed from the first preheat cycle, the second preheat cycle might be a little bit shorter due to the warmer air already present in the manifold.
And here's something most people don't know. If you only do one preheat, like a remote start with your key fob, or as I like to call it, a couch start, you're only getting about half the peak manifold air temperature improvement compared to 2 preheats. And 2 preheats are a big deal when it comes to sub-zero starts. So yes, it's inconvenient. You have to go outside and freeze your ass off, but it makes a massive difference. We currently offer 2 Monster Ram heating configurations. The standard Monster Ram comes with a single coil heater threaded into the casting at 750 watts. Or you can add a second heater totaling 1500 watts. We wanted to test how these 2 configurations would perform with and without block heat. But as you'll recall, there's more at play than just heating the intake air. We needed to know what happens to the engine coolant temperature as well as battery voltage before and during cranking. And we wanted to know the cranking RPM.
Before we got into cold start testing, we needed to baseline the truck's starting capabilities with the Monster Ram where the ambient temp was at least 66 degrees Fahrenheit. Remember, all Monster Rams for the 6.7 Cummins include a 750 watt coil heater. We didn't want to energize the heater circuit, which would have happened at 66 or below. So our baseline test was performed on a typical 75-degree California day. We measured a resting voltage of 12.6 volts, a cranking voltage of 10.8 volts, and a cranking speed of 154 RPM. Our first test series in the climate chamber was performed without a block heater. A single coil heater at 750 watts without block heat started the engine down to 0F or minus 18C. And, of course, with no block heat, the coolant temp was the same as the ambient temp thanks to the cold soak. Resting voltage dropped to 12.2 volts, cranking voltage dropped to 10.7 volts, and the cranking RPM dropped to 128.
You can see there was some degradation to the resting and cranking voltage and the cranking RPM. But remember, the batteries are rated down to 0F. So as far as batteries are concerned, we're just about to enter no man's land.
Looking at the Monster Ram 1500 watt configuration, we were able to start the engine down to minus 20F or minus 29C. The resting voltage fell to 11.6 volts, the cranking voltage fell to 9.3 volts, and the cranking RPM fell all the way to 82.
Well, welcome to battery no man's land. At minus 20F, we lost 1 volt before Eric even got in the truck, and 1.5 volts while cranking. But the interesting story with this minus 20 test is just how much the second preheat cycle helped with the manifold air temp. This graph makes it easy to see. Along the x-axis is time in seconds. Along the y-axis is engine RPM on the left, with voltage and manifold air temp on the right. The red line is heater circuit voltage. You can see our 2 preheat cycles here and here. The purple line is our manifold air temp. You'll note the first preheat was 30 seconds, which brought the manifold air temp above 0F. At 0F manifold air temp, the ECM reduced the heater on time to 15 seconds. Even with a shorter on time, look how the second preheat pushes up the manifold temp to damn near 16F. Now take a look at the blue line, engine RPM. You can see the engine cranked for 8 seconds, reaching 82 RPM, and at 82 RPM the engine just barely fired, even with the intake heat. To show you what I mean, let's compare the 154 cranking RPM on a warm day with the 82 cranking RPM at minus 20F. At 154 RPM, the piston travels 2.09 feet per second. At 82 cranking RPM, piston speed falls to 1.11 feet per second. That's a 47% loss in piston speed. You think that'll affect cranking temperature? Because on the compression stroke, you need the piston to come up rapidly to help create the necessary heat to reach the kindling temperature and ignite the diesel fuel. But you've lost 47% of the piston speed. Chances are, without our 1500 watts of intake heat and 2 preheats, it would have never fired at 82 RPM.
Now let's see how the engine cranks at minus 30. With no block heat at minus 30 or minus 34C, the resting voltage fell to 11.5 volts, and the cranking voltage fell all the way to 7.9 volts. And here's what that sounded like. Alright, logging. Alright, first preheat. Preheat going. It's a long one. Temps coming up. Alright, first preheat coming to an end. Power cycle. Off. 2, 4, 7. Accessory on again. Alright, second preheat cycle. Here we go. Shorter one this time. Alright, Curtis, cranking in 3, 2, 1.
Do you hear that starter fighting for its life? It only managed to spin the engine to 73 RPM, less than half the RPM of a warm day start, and far too slow to light it off. Now let's see what happened with the block heater on.
With the truck cold soaked to minus 20 or minus 29C and the block heater on, the coolant temperature rose to 32F or 0C. That's 52 Fahrenheit degrees or 29 Celsius warmer than the climate chamber. Remember, without block heat, the coolant would have been minus 20F. The resting voltage dropped to 11.8 volts, the cranking voltage dropped to 9.9 volts, and the cranking speed dropped to 96 RPM, which was 58 RPM less than our 75 degree warm day start. Now that we knew what a monster M with a single 750 watt heater could do in combination with block heat, we threaded in a second coil heater totaling 1500 watts. The additional intake heat allowed us to start all the way down to minus 30F or minus 34C. We measured a coolant temperature of 20F or minus 7C, a resting voltage that dropped to 11.7 volts, cranking voltage that dropped to 8.7 volts, and a cranking RPM of 89. Pretty slow, but she fired. Alright, second preheat cycle. Here we go. Shorter one this time. Alright, Curtis, cranking in 3, 2, 1. Alright, there we have it.
Having a block heater helps by warming the coolant, but we're still fighting frozen batteries and cold oil. Resting voltage fell by a volt, cranking voltage dropped by over 2 volts, and compared to our 75 degree warm day start, we lost 65 RPM while cranking. So far, we've started all the way down to minus 30F or minus 34C, and that's damn cold. But with that success under our belt and a climate chamber that would go to minus 40F or minus 40C, I said to the guys, button up your union suits, we're going for minus 40. And oh, by the way, minus 40 is where the Fahrenheit and Celsius scales meet.
Negative 38 and negative 40. Alright, you ready, Curtis? Okay. Accessory on. I'm going to restart the log. It's fresh zero data. Alright, logging. Give that a second. Alright, negative 40. Here we go. Nothing. Even with block heat warming the coolant to 9F or minus 13C, the battery's resting voltage dropped even further to 11.4 volts. And when we tried to crank, the voltage dropped all the way to 6.4 volts. The lights went out and the ECM left the building. In other words, 6.4 volts isn't even enough to keep the ECM alive. No ECM, no start. This is no longer a manifold air temperature problem. It's a frozen battery problem. The key takeaway here is cranking RPM is now 0.
I want to point out something important about these tests. Everything was optimal in our 24 Ram. Everything was as good as it could get. Fresh engine, new batteries, and the right fluids with clean filters. Chances are good your truck won't have all these advantages. While I can't give you a fresh engine, or new batteries, or the right fluids with clean filters, I can give you more manifold air temperature. Remember, air intake heat plus compression heat equals temperature at injection. So my suggestion is to ensure your cold start performance by adding an additional heater. The more wattage, the better. If we started the engine with 750 watts, I suggest you go with 1500. If you're a guy who vacations in cold country, 1500 watts is great insurance. If we started the engine with 1500, I recommend you go with our new triple heat kit, which comes with 2 additional coil heaters, totaling 2250 watts. Yes, that's right. I'm announcing our new triple heat capable Monster Ram. It resets the bar on sub-zero cold start manifold air temp. And our new triple heat kit is available now. If you live where temps require our new 2250 watt triple heat kit, I strongly recommend using a block heater. I swear, somewhere in the Bible, maybe Corinthians 6.7, it says, "Thou shalt use block heat below -20. Simply put, cold weather stacks the deck against a diesel. Compression temperature drops, and without heat, you get no combustion. Your engine is virtually a block of ice, and heating your intake is your only salvation. Remember, ambient temp is up to God, coolant temp is up to you, compression temp is up to the battery and your engine's condition. That's why we focused on intake heat, and we did it by producing the most accurate and repeatable test data possible. We didn't guess, we didn't simulate, we didn't copy. We put a truck in a cold cell and tested it over.
All right, we're at negative 34.4 Celsius, back at negative 28.9 degrees Celsius, minus 40 Celsius,
and over.
Let's go on in and freeze our asses off.
We've pioneered a patent-pending intake system that gives you control over intake heat with scalable wattage and eliminates the failure-prone factory grid heater. And for you guys with the original single heat Monster Ram, we have a direct bolt-on solution for you too. You can add 750 watts with our single billet heater kit, totaling 1500. Or you can add 1500 with our dual billet heater kit, totaling 2250 watts. The new triple heat capable Banks Monster Ram is available at bankspower.com or any of our hundreds of authorized installers. My fingers are getting cold.